All right, ladies and gentlemen, today we are talking about multiplying and dividing fractions. Please make sure you correctly label your outside upper corner of your notebook. You should be on page 7, and today is September 3rd, 2013. Yesterday I had you start setting this page up, or sorry, over the weekend, I had you start setting the page up. Our objective today is that you can multiply and divide fractions successfully, and that you can show multiplication on a number line. We're doing a lot with number lines today. I mentioned it in the last video. Common Core, which is the new set of state standards, is huge on number lines, so you really need to make sure that you understand it. I'm going to show you two different models for multiplying fractions. A lot of you already know the basics of how to multiply fractions, but you might not really know why it works, and the why is always more important than the how. So we have two different models for multiplying fractions, and the first one that we're going to talk about is on a number line. So go ahead and write down here, remember that multiplication is just repeated addition. So how about we go through a repeated addition example? You don't have to write this down, but please watch carefully. Let's say, for example, I have the multiplication problem 2 times 3. If I were to put this on a number line, I would go ahead and number my number line. And when you think of multiplication as repeated addition, 2 times 3 becomes 2 plus 2 plus 2. We have 3 2's that we're adding together to get 2 times 3. Just the way we showed addition a couple days ago when we put fraction problems on the number line, we're going to show addition kind of the same way here. We start at 0, we add 2, that's the first step. We add 2, that's our second step. And we add 2 again, that's our third step. We ask ourselves, what number did we come up with? And we have 6. Okay? That's an example with numbers you might be more used to. Now let's talk about an example with fraction numbers. Let's say I use the example, I'm going to write it over here on the side, of 1/3 times 4. Okay? And I'm going to draw my number line. I'll go ahead and put a 0. I'm not going to need a ton of numbers on this number line, so how about I just do 1 and 2. If I start with thinking about this multiplication problem as repeated addition, it's going to be 1/3 added to itself 4 times. So 1/3 plus 1/3 plus 1/3 plus 1/3. So on my number line here, I can represent that with repeated addition. I start at 0 and I go 1/3. That puts me here, 1/3. If I go another third, that's going to put me at 2/3. Another third, that's going to put me at 1/2. And then my final third will put me at 1 and 1/3. And that's where I end up. Okay, so you can show multiplication on a number line by using repeated addition. Okay? Replay that if you need it. Pause it, take down the notes, whatever you need to do in order to understand that concept. There is another way of showing how we multiply fractions, and this is called the area model. You can go ahead and put this still on page 7, the bottom half of the page. If you wrote too big, go back and rewrite it. You guys need to be on the same page in your notebooks as I am. So for the area model, for multiplying fractions, area, a lot of you guys know what area is. Area of a basic rectangle or a basic square is simply length times width. That is a multiplication problem. So why don't I take an example with normal numbers again? Let's go ahead and use 2 times 3. I have over here on the right side of my page a rectangle. And this rectangle is 2 blocks by 6 blocks. Okay? I'm sorry. Scratch that. It's 2 blocks by 3 blocks. And when you have a rectangle that is 2 blocks by 3 blocks, you end up with blocks. Okay, that is the basic area model for multiplication, and we can use that in a fraction problem. So I have another block down here, and I'm going to use this block to represent fractional multiplication. Let's say I take 1/2, and I want to multiply it by 1/3. If I look at this side of my rectangle, and I think of this entire side as one whole, with me so far? I can take half of that side, and that can represent 1/2. So I'm going to go here into my rectangle and kind of shade in the top half here. It doesn't have to be perfect. That represents my 1/2 fraction. Okay, that's shown in the red. My 1/3 fraction, I'm going to use the other side. Just like up here, I put 2 on one side and 3 on the other. Down here, I'm putting 1/2 on one side, and down on the bottom, I'm going to put 1/3. The entire length of the rectangle represents one whole, and 1/3 is this section here. So I'm going to go ahead and shade that section in. Now, when I'm looking to find my actual answer to this multiplication problem, I'm going to ask myself, where is there a rectangle that has both colors? There's only one place where the 1/2 and the 1/3 overlap. It's this one section right here. So ask yourself, how many little sections do I have out of my entire total rectangle? I have one little section out of 1, 2, 3, 4, 5, 6. 1 out of 6. That is my multiplication model for multiplying fractions. Make sure you understand it, okay? If you need to go back and look at it again, you can. I'm going to do another multiplication problem for you. So I'm just going to divide this rectangle up a little bit more. Okay, so now I have 1, 2, 3, 4, 5, 6 sections across, which represent one whole. And I'm still going to keep the 2 sections here, which represent 1/2. So which represent one whole, and each section would be 1/2. So my problem that I'm going to do now is 5/6 times 1/2. I'm going to go ahead and go back in using my numbers, my colors. 5/6, that's going to be 5 of these sections over here, shaded in. Okay. And then 1/2 will be half of my sections going across here. So now you need to ask yourself, how many sections have both colors? In this case, it's 1, 2, 3, 4, 5 sections. And how many total sections are there? There are 12. Okay? Alrighty, let's go ahead and move on. If you could go to page 8 now of your notebook and go ahead and put the date, September 3rd, the page number, page 8, and the title, Multiplying Fractions. These are going to be our written notes for actually performing the multiplication. Step number 1. If the fractions are mixed numbers, change them to improper fractions. You might notice this is the same first step that we had with adding and subtracting fractions. If they're already just a regular fraction, if they're not mixed numbers, don't change them. It's going to mess you up because you will do it wrong. Step number 2. Step number 2 is to cross-cancel if possible. And I will show you in just a minute what cross-canceling means. But you do need to remember, this is so important and possibly the most important lesson of the day. You need to cross-cancel vertically or diagonally only. You cannot cancel horizontally, and I will repeat that again in a couple minutes when we work through some examples. Step 3, multiply the numerators and then multiply the denominators. Step 4, simplify if possible. Many people find multiplication and division of fractions to be much easier than adding and subtracting them. So let's go ahead and work through a couple examples. Still on page 8, over on the side, go ahead and write example 1. You can write it under where you took the notes. And let's go ahead and do a simple one. Something like 2/7 times 1/5. How about that? If you look back to our notes, step number 1 says, hang on. Step number 1 says, if the fractions are mixed numbers, change them to improper fractions. Ours aren't. We are good. They can stay just as they are. Then it says cross cancel vertically or diagonally. We're going to skip this for now, and I'll show you on the next problem. And then step 3 says to multiply the numerators and multiply the denominators. So 2 times 5 is going to equal 2. 7 times 5 equals 35. The last step in multiplying fractions is to simplify if possible. 2 out of 35 is already simplified as much as it can be, so we can just put a box around our answer and we're done. Let's do another more complicated example. Example 2. Let's go ahead and do 1 2/3 times 9/14. How about that? That'll be good. Step number 1 in our note says to turn any mixed numbers into improper fractions. So to do that, this first fraction here is a mixed number. We need to take our denominator, multiply it by our whole number, and then add the numerator. So 3 times 1 gives me 3. If I add 2 to that, that gives me 5. My denominator is going to stay the same, so that becomes 5/3. And then over here, I still have 9/14. 9/14 was not a mixed number, so it can stay just as it is. Now here's where we get to the part about cross-canceling. Now not all teachers call it cross-canceling. I call it cross-canceling. It just makes sense to me. If another teacher has called it something else, wonderful. You can cross-cancel vertically or diagonally, not horizontally. Let's look at what that means. In this problem, I have my first fraction is 5/3. I want you to notice that I have over on this side a 9 on top and a 3 on the bottom in the first fraction. My question for you is, do they have a common factor? Is there any number that goes into both 9 and 3? And in this case, I hope that you say, yes, there is. They both can be divided by 3. So what I'm going to do is I'm going to cross out or cancel this 9, because 9 divided by 3 becomes 3. And I'm going to cross out this 3 down here, and 3 divided by 3 is 1. What I just did was canceled diagonally, going across this way. You can cancel that way. One more. There we go. If I then rewrite my problem in a way that's a little more organized without all the x's on it, I now have 5/1 times 3/14. I can't do any more canceling here, so I'm going to go ahead and just multiply my numerators. That gives me 15. Multiply my denominators, which gives me 14. And then to simplify it, I need to turn it into a mixed number. 14 goes into 15 one time, and you have 1 left over. That is your final answer there. Stop, rewind if you need to. Okay, I'm going to give you one to try on your own. And then, hang on, my eraser is non-functional. There we go. All right, I want you to go ahead and try this one, see how it goes. 5/9 times 12/15. Go ahead and pause the video now and try this problem using your canceling, your cross canceling, and see what you can come up with. When you're ready, hit play again. Okay, hopefully at this point in time you have paused and you have tried the problem. If not, stop it now because I'm going to yell at you. All right, so when we go to solve this problem, we don't have any mixed numbers, so we don't have to change anything to an improper fraction, but we can cancel some things. We have a 5 up here and a 15 down there. Those numbers have a common factor. They can both be divided by 5. So as I go through this, I'm going to cross out this 5. 5 divided by 5 is 1. I'm going to cross out the 15. 15 divided by 5 is 3. Hopefully you got that far at least. I can also cancel my 9 and my 12. Both of those numbers are divisible by 3. If I take my 12, I can cross it out. 12 divided by 3 is 4. I can take my 9, do the same thing. 9 divided by 3 is 3. Now that looks kind of messy, so how about we rewrite it on the next line so we can make sense of it. I have 1 over 3 for my left fraction times 4 over 3 for my right fraction. That's a lot simpler of a problem, and we like that. So now let's go ahead and do our multiplication of the fractions. 1 times 4 is 4. 3 times 3 is 9. Our final answer is 4 over 9 because you cannot simplify that any further than it already is. Okay? Now let's actually put some of these ideas about multiplying fractions into a real-world situation. This is going to be on page 9 of your notebook. Please make sure you put the page number and the date. And in just a moment, I'm going to ask you to pause the problem and see if you can figure it out on your own. And then I'll show you what the answer actually is. Ready? Go ahead and pause now. Okay, let's go ahead and start this problem first by reading the whole thing out loud. On Friday night, John ate pizza for dinner and had 1/2 of the pizza left over. On Saturday, he ate 1/3 of what was left. How much pizza did John eat on Sunday? Okay, so we start out by finding our numbers. We have 1/2, we have 1/3. We also have a very, very important word in this word problem, and that word is of. Of, ladies and gentlemen, means multiply. I want you to write that in your notebook and circle it because it is so important. When you see of in a word problem, it almost always means multiply. For example, 20% off of the price of a sweater. You take 20% and multiply it by the price. 3/5 of the students in the class. If there are 20 students in the class, I would do 3/5 times 20. Of means multiply. So John starts out with a whole pizza, 1 whole pizza. He has 1/2 of the pizza left over. That means he ate 1/2 of it. So he had 1/2 of the pizza. Of means multiply. There we go. And then on Saturday, he ate 1/3 of what was left. Times 1/3. So now when it says how much pizza did John eat on Sunday, we're looking for how much is left over. All right? So if we go ahead and do this multiplication, we can kind of knock out this number right away. Any number multiplied by 1 is the number itself. So this 1 we really don't need. We can take a look at our fractions now, and we have 1/2 times 1/6. We multiply our numerators to get 1. Our denominators give us 6. So you should have come up with 1/6 of the pizza. All right? All right, let's do another one. Oh, this example is a little bit more complicated. You know what? This example I don't want to do right now. We're going to work on that example in class tomorrow. So skip that example, leave that room on page 9. We'll do it in class. Let's talk about dividing fractions. Please go on to page 10. You should have gotten a handout from me in class today that looked like this, and I told you how to put that in your interactive notebook. Dividing fractions is really simple, guys. Really, really simple. It's just a couple basic rules. And those basic rules are leave, change, and flip. Please write these in, just as I have underneath the foldable. Leave it, change it, flip it. You've probably heard this before or some similar phrase to that. And what it means is we're going to take the first fraction in our division problem and we're going to leave it, just as is, 3/6. We're going to take the operation, in this case division, and we are going to change it to multiplication. We are going to take the final fraction in our division problem and flip it, so that instead of 7/12, we have 12/7. And then, guys, it's just a multiplication problem. It's just a simple multiplication problem. This is a problem that I can cancel. Remember, I can cancel diagonally or I can cancel vertically. How about we cancel vertically on this one first? I have a 3 and I have a 6. Both of those can be divided by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So that becomes 1/2. I can also cancel diagonally. I have 2 and 12. Both of those can be divided by 2. Cancel the 2 and it becomes a 1. Cancel the 12 and it becomes a 6. What I'm left with then is just a simple 1/1 times 6/7, which gives you 6/7. Division is not hard as long as you remember, leave it, change it, flip it. Okay? Let's go ahead and try an example on your own. Pardon me. Ooh, let's do one with mixed numbers. This should still be on the bottom half of page 10. So let's take 1/2 divided by 5/4. Okay? With this mixed number here, that is going to mess us up. So let's change it to an improper fraction. 2 times 1 is 2, plus 1 is 3. Keep the same denominator of 2, so that gives us 3/2 divided by 5/4. The rules for dividing fractions are leave it, change it, flip it. I'm going to leave my first fraction as 3/2. I'm going to change my division to multiplication, and I'm going to flip my final fraction to 4/5. Let's do some cross-canceling. I have a 4 on top and a 2 on bottom. Those are both divisible by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. If you are confused at this point, go back and look at what I talked about with cross-canceling. Really be comfortable with that before you move on. Now I simply multiply. 3 times 2 is 6. 1 times 5 is 5. My final answer is 6/5. I can turn that into a mixed number, which would be 1 1/5. All right? Let's see, what do we have next? All right, let's go ahead and do one example with dividing fractions in a real-world word problem. Go to page 11, put the page number and the date, make sure you put a title here, dividing fractions. You could write dividing fraction examples, just a clear title. And I want you to once again try and solve this problem on your own, and then play to see if you got the right answer. Hit pause at this time so you can try and solve it. Okay, so we have the following question. How many 2 3/4 foot long strips of ribbon can be cut from a ribbon that is 7.5 feet long? I'm going to draw a picture here. I have a ribbon. You like my ribbon? It's beautiful. And I'm trying to cut this ribbon into pieces that are all 2 3/4 of a foot long. That's a division problem, guys. It's like if I had a board that was 8 feet long and I wanted 2-foot sections. Well, duh, it's going to be 4 sections that you can cut. In this case, it just has fractions, but it's really not that complicated. The entire length of the ribbon is 7.5. We want to divide it into pieces that are 2 3/4 of a foot long. We have mixed numbers here, so let's change them to improper fractions. 2 times 7 is 14. Add 1 gives me 15. Keep the denominator of 2. Divided by 4 times 2 is 8. Plus 3 is 11. Keep the denominator of 4. And now I'm going to use my leave it, change it, flip it rule. 15 over 2. Leave that first fraction. Change division to multiplication. Flip the second fraction. And look at this. I can do some cross canceling. I have a 2. I have a 4. They're both divisible by 2. 2 is going to become 1. 4 is going to become 2. That's all the canceling I can do. I then multiply my fractions. 15 times 2 is 30. 1 times 11 is 11. So I have 30 elevenths. If I turn that back into a mixed number, it's 2. 11 goes into 30 2 times, and I have 9 left over. So 2 and 9 elevenths. I can't quite get 3 pieces of ribbon out of my long piece of ribbon. I can get almost 3, so I can get 2 complete strips. Okay, so that would be your answer. 2 complete strips. All right. Ladies and gentlemen, we'll do some more work on these kind of problems tomorrow. Make sure you study this, make sure you understand this so that you can get the questions of the day right and move on to the enrichment group. Thank you. Have a good night. Bye-bye.